As you know that because of the density, we have gas, then we have the oil, and then we have the aquifer, which is the water. And what we do, we put the well. Usually we put the well in oil zone, as I have always told you, because our main concern is to produce oil. This is one of the reasons. The another reason is the this gas that we have is act like the like a cap. They act like a piston and try to keep the pressure on this oil. So this is the second objective that we achieve using this one. Then after a certain time, when our reservoirs get old, the pressure has declined over time, and the pressure of the reservoir is always declining with time. So once the pressure is declined, we need another mechanism, and in this case, we have gas injection. We inject the gas here. We try to inject the gas here, or we inject the water, and they try to increase its volume, and by increasing the volume, we increase the pressure. It's simple by Boyle's law and Charles law, where pressure and volume are connected to each other. We follow that one, and we try to maintain the reservoir flow. And fortunately, in Kurdistan region, our main reservoirs are still on primary production. We don't need any secondary process right now. The pressures, as we have visited the Circula or the Gazprom or Dana Gas, their pressures are very, very good. For example, in Circula, the pressure was 7,000 psi and onwards. So they don't need any pressure maintenance right now, and which is good for Kurdistan region so far. And as you know that then after, once the pressure is too much decline, we go for the enhanced oil recovery, and then we try to inject some chemicals, some polymers, some surfactants in the reservoir, and objective is to make the oil more mobile, more easy to flow. It is same like a detergent in your home that you use for clothing purpose to remove the dirt out of it. So if you just use the water, the dirt will not come out of your clothes. But if you use the detergent, you will see that by using the detergent, you remove the dirt out of it. So by that one, we use those surfactants. Detergent is actually also a surfactant. So we use those surfactant polymers and foam, and there are so many other methods that we have. For example, in situ combustion, we have steam flooding, we have chemical flooding, we have microbial flooding, you name it. We have so many options that we do. And these UR methods right now, especially in US, they are following it a lot. In Abu Dhabi, UAE fields are quite mature. We call them brown fields, those who are on EOR. So they are following these processes. Now, these processes are very complicated, and they are not done unless the reservoir simulation studies are conducted. So all these mechanisms that you see, it has to be done using this uh, reservoir simulation softwares. So now the question comes here, why reservoir simulation is needed? As I discussed before, well, we need it in order to understand the reservoir and the fluid behavior. We need to know that how the oil is behaving. Now, when I say the fluid behavior, what does it mean? It means that how the pressure is behaving, because right now the pressure is 2000 psi. The well is flowing, it's fine, but maybe after uh, 5 years, 6 years, the pressure may decline. If the pressure may decline, then you will not get the same production as of now. This is the first thing. Then, secondly, how about if the water production increases or the oil water level increases, and so on? So these things exist, and there are so many things that needs to be discussed about it, and that we will continue throughout the semester, throughout the course about this. Then, first of all, how much oil we have in the reservoir? It's a simple question. Everyone would like to know. For example, how much oil Kurdistan has? So, well, this study needs to be done, reservoir by reservoir. So we have to quantify. We have to quantify the uncertainty, what's going on, and so on. And later on, when we have to look at it, the compare scenario, we have to look at the hypothesis. For example, we have our reservoir model, and we want to know that how many wells we need to put to produce maximum. For example, we have a field in Kurdistan, let's say in Circula. So the field is around 5 kilometers. It's big field. How many wells we should put in it? 6 wells, 10 wells, 20 wells, 30 wells, 50 wells, 100 wells, so on. I mean, how many exactly? So what we do, we do the scenarios. We have our reservoir model. Make sure that the model you are using, it has to be 100% accurate as per original field. I mean, the performance of your mathematical model has to match with the performance of real physical performance of the well, of the field, plus the wells. If the performance is matched, then you can rely on uh, the results and so on. So, for example, mathematical tools, simulator are just the tool. If you put the garbage, you get the garbage. If you put good data, you get the good data. Results, good results. So it's all depend on your input, what input you are putting in that case. Let's go on, and what kind of answers it can help. Well, first of all, as I said, how should our field be developed to maximize the economic recovery? Well, it means that how many wells we should put. It's as simple. Well, if the pressure is decline of your well or your field or reservoirs, what is the EUR method which is good for you? As I said in the previous slides, that there are so many options that we have. We have water alternating gas injection, we have in situ imbection. I mean, which one is good? So we need to compare. We need to look at it into deeper. We have to study what kind of EUR may be good for our reservoir to increase oil production, and whether it will be economic or not. Whether, I mean, we spend $1 million on it and we are producing only 500, 400,000, and operating cost is too much, then what is the point? So we have to look at economically about this issue. And then why is the reservoir not behaving according to predictions made by previous engineering studies? We have to look at it. For example, we predicted that, okay, well, this problem happened in Kurdistan. Jinel was not expecting the water production that they have today. Well, they did the studies, okay, their reserves are a lot, but after 2 years, their water production increases and their production declines, and then they have to manage those water. So their previous studies didn't behave as they expected. Water level raised. Why? We don't know. They have to do the study. Why the water level increased? So these prediction has to be made. And as I said, the most important question is how many barrels of oil we are going to produce from this reservoir. This is the question. I mean, for example, if the field uh, gives me $50 million for in next 10 years, but the cost of maintaining that field is $1 billion, then what is the solution? So we have to look at that how much oil we have. Then you can invest in the money, or your company can invest the money in this kind of fields. Then secondly, then what kind of laboratory data is required? Then we need a lot of laboratory data. As you know that, as you have studied before, that you need to know about the porosity of the reservoir, permeability, and so many other data that we need, relative permeability data that we need. We need to know uh, what is the temperature. We need to know composition of the crude oil that we have. So we need lots of laboratory things in order to run the simulation models perfectly. And completion schemes, where exactly you want to complete your well, do the perforation, and so on. So there are so many questions that needs to be answered here in this case, and